Thank you very much for coming today and welcome to our session on citizen science and using community collaboration to create new science. I'm very, very pleased to be joined by Alphonse Smith and Jeff Holmes today on the panel, and each of them is going to talk to you for longer than I will. So I'm really looking forward to hearing about both Zooniverse and the Encyclopedia of Life. So for the Twitterers in the audience, Jeff is not a Twitterer, as we've just discovered, but Alphonse and I both are, so there are our Twitter handles up there. And I forgot to look up, each session has a Twitter hashtag as well for the specific for the session, which is in your conference booklets. So the plan for today is that I'll give a shortish introduction and a bit about some of the citizen science projects that are happening in Australia. And then Arvon and Jeff will each give a longer talk, and we've got some discussion questions to talk about at the end, and I'm hoping that this will stimulate quite a bit of discussion so that it's not just us talking to ourselves. So to start off, what is citizen science? By way of describing it, I'll say what it's not. It's not a new thing. Citizen science is something that amateur naturalists, stargazers, bird observers have been doing for hundreds of years. This photograph, for example, shows the members of the Victorian Field Naturalists Club in 1893 during an expedition to the Furneaux Islands, which are a little group of islands in between the Australian mainland and Tasmania in Bass Strait. So, as far back as 1893 in Australia anyway, people were heading off to go and document the fauna and the flora of the country, to find what they could about the natural world. And it's often the amateurs who make the important breakthroughs, as they're very passionate, they're very informed, and they work at constantly improving their knowledge. So institutions are increasingly calling on people to help them with all sorts of work, from undertaking biological surveys where they are actually going out and collecting new data, to identifying galaxies. And also in the humanities, so citizen science isn't something, or crowdsourcing isn't something that's restricted to sciences. In the humanities, we've got projects ranging from document transcriptions right through to many, many others, including projects in Australia like correcting OCR in newspapers, in digitised newspapers. I guess one of the prerequisites for being able to allow people to do that is that institutions have to be ready and willing to make their data open. And that can present a bit of a problem, an authority problem sometimes, because particularly if you're doing something like offering up a project where you're seeking help with improving the data, so the OCR transcription or something like that, you're offering up dirty data. And that can be problematic and can be challenging for museums to think about putting their dirty data out and hoping that people will help them to clean it up. So there are many, many citizen science projects these days, so many that sites are now starting to pop up that aggregate project sites and point interested users to where they can find out more information about how to go about participating in citizen science projects. And I've put just a couple of the sites that I know of up here. One is SciStarter, which has lists projects from all around the world, where citizen science, people who want to do citizen science can get in touch with people who are running the projects. And there are some museum projects listed up there. There's also the Citizen Science Centre, which runs more like a sort of a rolling blog, but also gives a lot of information about projects that people might want to participate in. So projects are running within museums and outside, and plenty running outside of museums. A couple of projects that are the big outside museum projects that are worth mentioning are projects like Project Noah, Project NOAA is run in collaboration with National Geographic, and its focus has sort of almost by default come onto photography, and the photography that gets uploaded into Project NOAA is absolutely extraordinary. They're finding the most beautiful images and having them posted up there, and it's really worth going and checking out Project NOAA just to look at the amazing images. Climate Watch is an Australian project run by the Earthwatch Institute, and what it's asking to do, there are similar projects operating in the UK and elsewhere, where what they're looking for is phenological data, so data about phenomena. So, for example, they might be looking for the first sighting of a particular butterfly flying in the spring, or the first turn of the leaves in fall. So they have these projects are not sort of projects where you're asked to cite everything and record observations, but more that there's a specific species list, and they ask you to record sightings of just those particular species. So they're working outside of museums. Within museums and within Australia, we have the Atlas of Living Australia. So the Atlas of Living Australia is a multi-million-dollar project that seeks to aggregate information from museums and herbaria, as well as including information from government departments and observational data from organisations like Birds Australia being sort of the bird observers amateur naturalists club in Australia. So the combined total records that museums right around Australia, so 13 museums right around Australia contribute into the Atlas of Living Australia, so these are specimen records, is about 2.5 million records. Just by contrast, Birds Australia contribute about 8 million observational records. So all of the museums around the country get 2.5 million. One organisation contributing observational records is 8 million records. The Atlas has been going for a few years now and seeks to not only provide information to the natural history collections in museums and herbaria around Australia, but does seek active participation of the community. So you can see the big block up there saying sharing biodiversity knowledge. One of the things that they ask for is for anyone to provide information about sightings of species and get ways of getting involved. We certainly know that that's a popular thing to do. At the museum where I work in Melbourne, we have a public inquiry service, and we do get people ringing up and saying, look, I've just seen this whatever, this owl or this bird or this whatever. Someone must want to know about that. And we say, yes, now we can say, in the last couple of years, we can say, yes, somebody does want to know about that. Put your sighting onto the Atlas of Living Australia. Previously, it was difficult for us because we'd say, I'm sure somebody wants to know about it. We don't specially. So now we have a place that we can point people to, which is really good. One of the projects that the Atlas is running is called the Biodiversity Volunteers Portal. So there's a couple of different types of citizen science. In natural history museums, often the citizen science projects that are being run are asking people to go out and do field work or create observations, actually gather data and send it in. In other cases, the tasks are more of an analysis-based nature. In the Biodiversity Volunteers Portal, the volunteers are certainly being asked to help with information production on an analysis sort of basis. So what they're doing, this project, photographing butterflies, and there's many other types of animals that are being photographed, is to help with the difficulty that many museums face about the backlog. How do you make any sort of progress with the backlog registration? Particularly for collections which have, say, big entomological collections where there's usually millions and millions of specimens written up in handwritten registers, but very difficult to get that information into a database. What they're doing at the Australian Museum is to photograph the animals. That they're taking the labels off the pins so that people can read the labels, taking the photographs and then asking for assistance from volunteers to transcribe the labels. And in that way, they're getting much better data about the species name, the locality data, the date collected and the collector, that sort of information, which is all being fed back into the collection management system and then up into the Atlas of Living Australia. They've also started experimenting with doing things like asking for help with transcription of field notes. So in Australia, as elsewhere, field notes are starting to be sort of dug out of the archives and plucked off people's shelves where they might have been sitting for a long time. And I know there's a big project that's happening in the Smithsonian institution as well around field notebooks. What we're doing with Australia is digitising those field notebooks and then asking for those to be, for assistance for those to be transcribed. What we're doing though is trying to, and there'll be another talk, I think tomorrow afternoon, which talks about this as well, is not just asking for transcription where you end up with the text and nothing more. What we're asking to do is to actually pull out locality data, pull out species names, pull out date data, so that we can link up information in the species in the field notebooks with specimens that we have in the collections. So that's a little bit about Australia. In Australia, in Australian organisations as well, we're going mobile because that's what everyone's doing, and a number of institutions have started to explore this idea of gathering data through mobile apps. So the Australian Museum again has produced a field guide app to frogs, where people are asked to submit their sightings. Similarly, down in Victoria, we seem to love frogs in Australia. Down in Victoria, a local catchment management authority called the Goulburn Broken Catchment Management Authority has worked with us at Museum Victoria to produce a field guide, an app-based field guide to frogs in their area. And again, they're asking for people to report sightings of those particular frogs. It's just a limited set of about 20 frogs that are known to occur in their area, and their sightings get reported back into a website, and you can visualise those sightings on a website. Interestingly, when I looked at the website the other day and looked at sightings, there were sightings that had been reported from as far away as Chile and North America, and I'm not quite sure how endemic frogs from Victoria, from a small region in Victoria, ended up being sighted over in Chile, but there you go. We can only assume that it was somebody who got hold of the app and thought, yeah, let's do this. What does this button do? So there's always a difficulty with weeding out spurious records. Lastly, I'll also just mention, just so that it's not completely Australian-based, a project that has been run by Columbia University, the University of Maryland and the Smithsonian, which allows users to identify leaves. It's called Leaf Snap. You take a photo, and many of you might have used it, you take a photo of a leaf and get information and record sightings of particular trees. So those are a few apps that allow you to upload data. At our museum, we're also looking at using mobile tools just simply to allow museum science to get out into the community. So Museum Victoria has produced 2 field guide apps so far, and this platform for us is now sort of replacing the traditional publication method of producing field guides. The first is the Field Guide to Victorian Fauna, which is just a screenshot up here. That was produced in 2010, and there's been several museums and the web papers written about this field guide. Since 2010, when it was launched, there's been over 43,000 downloads of the app, which we count as a success. We've also open sourced the code, which has also been a success. So open sourcing the code is what allowed the I Spy Frogs people to come along and create their own app. There's another app that's in the process of being developed with the same open source code by some folks over in Auckland in New Zealand. The Field Guide to Victorian Fauna contains 700 species in it, from marine to freshwater to terrestrial, all sorts of animals. It was only released for iOS devices, because we just didn't have the programming capability of allowing other platforms to be supported. But hot off the presses, and not even released until next week, so you're getting the very first look, is a new field guide which is to a local marine national park. It's going to contain 325 species, containing a whole lot of amazing photography. So the scientists actually went out into the field down to Bunurong and took all the photographs, partly to get around the issue of needing to go and seek copyright permissions from external photographers, which can be very laborious and time-consuming, and which is what we did for the field guide. This time the photographs are all ours, so we can openly license them and make them available freely for reuse. So both of these guides will, so the field guide's free, the Bunurong guide will be coming out for free next week. It's actually already in the App Store, so if you look for Bunurong, it's already in the App Store, but the media and comms will all start next week. We also use the Bunurong field guide as a way of porting the code across to Android. We had a little bit of money, so we used that to move the code across and produce an Android version. So this time an Android version will also be produced, and we hope that responds to some of the feedback that we've had from users about where's the Android version. The next project is to go back and re-engineer the field guide, the original field guide, into Android, so that we can get back to those people and say, it's out now, finally, here you go. Interestingly, making these apps free for us hasn't actually resulted in any sort of loss of revenue. So we're putting them out for free, so we're not making our 99 cents or our 66 cents or whatever it is for every app sale. But what's interesting is that we've pulled in about $500,000 worth of grant funds on the basis of the free apps. So what we've been able to do is to go out to funding bodies and say, hey, look, we've got this fantastic app platform. It's got the code is open sourced, the images are all open, they're freely available. Can we do something with you? Can we work with you? So the new set of apps that are coming in, which we got a large grant to be able to produce, will produce field guides for right round Australia. So that's just a very brief overview about how we're getting museum science out and how in Australia we're asking for citizens to start to contribute to science. So having given a lightning overview of some of those projects, let's switch back to the international scene and to citizen science globally, and away briefly from natural history and or specimen-based natural history anyway. So I'm very pleased to introduce today our first speaker, who's Avon Smith. He's the Director of Citizen Science at the Adler Planetarium in Chicago, and is also the technical lead of the Zooniverse project. For those of you who were just in the keynote session, Curtis Wong mentioned Galaxy Zoo, which is one of the Zooniverse projects. So, with a little bit of technical trickery, I will hand over to...
Okay, let's see how we get on. Hello, everybody. Okay, this should be seamless. Famous last words. Okay, so yes, thanks for the nice introduction. So the Adler is in this network of organisations that build Zooniverse projects. These are web-based citizen science projects. So there's 7 organisations you can see along the bottom there, who and the group are invested in building projects that engage members of the public in research questions, so research is kind of of prime importance to us, academic research questions that can only be answered through engagement with large numbers of people. So these are projects that cannot be done in any other way. And so today I'm just going to kind of take you on a tour of some of the stuff that we've done. I think it's worth saying, and I know some of this has just been covered already, but there's lots of terms that are used sort of interchangeably, I think, in citizen science, maybe crowdsourcing, citizen science, PPSR, CBSR, I don't know if people know these. These are public participation in scientific research. CBSR is community-based scientific research. Lots of acronyms, lots of people talking generally about the same thing typically. But of course, something crowdsourcing where there's actually this kind of data collection, like the kind of frog sighting project you were just showing us, the kind of powerhouse project here in the US is the Cornell Lab Ornithology's eBird project, which asks members of the public to cite birds, record sightings of birds, submit them to a central data set, which they can then use to do incredible science showing diversity, population changes, and diversity of species and how that's changing over time. This builds on a network, of course, of people who are already invested in the topic, the amateur birders. And so I think this is kind of a classic example for me of crowdsourcing data. So people submitting data, taken as a whole, these data sets produce richer data sets than any individual could produce. Volunteer computing is one of these kind of weird citizen science projects for me. I don't actually think this is citizen science, for the record. I don't think volunteer computing is the same as going out in your backyard and doing something. My reason for saying that is I think this is a very passive thing to be doing as an individual. You set up a screensaver on your computer, then you just let it run. I think it's still a contribution to a greater good, if you like. And there's a whole suite of projects that are built off the platform that SETI at Home first developed with the Boink project. But I think this is different, and I actually think volunteer computing is out on a sort of on a limb really in the citizen science space. And then there's something like Galaxy Zoo. So this is one of our projects. This is the 4th version of it that I launched this summer. And Galaxy Zoo is about crowd analysis. So people interpreting a piece of data for us, but crucially not submitting data. We don't ask people to send their pictures of galaxies into us. We just ask them to look at galaxies we have and say something about them. And Zooniverse really, I think, is about this, this is how I like to tell the story now. This isn't why we set up Galaxy Zoo, but this is a plot that gets used a bit too much these days, but it's still new for some audiences, so hopefully you haven't all seen it before. This is an infographic from Information is Beautiful, showing the amount of time that the US public spends watching TV every year. So this big box here is the 200 billion hours that the US population spends watching TV. And the little box down here is the amount of time that it took to create all of the content in Wikipedia. And so, the idea here being people have lots of spare time, and sometimes they use it to produce content on Wikipedia, and sometimes they're watching American Idol. But this idea is actually named. This is this thing called cognitive surplus. So there's spare brain capacity. People have time on their hands. Maybe they're watching TV, or maybe they're doing something else. But there is a surplus of human attention. And this is a book by Clay Shirky, who is sort of commentates on trends in the web, and that's underselling him, I would say. But one of his ideas is cognitive surplus, and he tries to put a number on it. He says there's about 1 trillion hours a year of this available, and some of it's available on the web. So people who are there and are maybe looking for something to do, and so. Clay Shirky comes up with this idea of the spectrum of cognitive surplus. So the spectrum is about engagement and what people are doing with their time. So at one end, we have lolcats, which are, if you don't know, these are pictures of cats doing funny things with a caption. And he's saying at one end we've got lolcats, which are they take time. People either take a funny picture of their cat and then think up a funny caption, but then they share them with a community of people who also like lolcats. So this is kind of a communal activity. It is cognitive surplus. It takes time, but you're sharing them with people who like lolcats. And at the other end, you've got citizen science projects like eBird, Foldit, Stardust at Home. And the distinction he makes is that this end is communal and the other end is civic. And so civic is, so you're producing content, you're devoting your time, but something that you're producing is enjoyed by society as a whole. And I think citizen science is towards this end. And so it's not that 1 trillion hours a year is available exclusively for citizen science. That's not how people want to relax. But there is a spectrum of engagement, and there's an opportunity to kind of build experiences that kind of try and draw people in this direction. So Galaxy Zoo started for a very simple reason. If we go back 5 years, we were a bunch of astronomers at the University of Oxford, and we had a problem. There was this telescope built by a group. This is the Sloan Digital Sky Survey Robotic Telescope. So in the plot that Curtis was sharing today in Worldwide Telescope with all the pictures of the galaxies. This is the telescope that took all those pictures. And so it surveyed about a quarter of the sky in the Northern Hemisphere, and it produced millions and millions of images that were of interest to the astrophysics community. And apologies for the astrophysics lesson here, but what astronomers like to do when they see a picture of a galaxy is try and put it in this kind of space. So this is called the Hubble tuning fork. It was invented by Edwin Hubble in the 1930s. And there's basically two types of galaxies. There's things like our own Milky Way, which is a spiral galaxy with a bar in it. And these big things are basically the same, these spirals. And we've got ellipticals at the other end, this kind of fuzzy ball of stars. And so if we look at Hubble images of these things, then this is this kind of classic big spiral galaxy, grand design kind of spiral, and this is an elliptical. So they're very distinctive looking objects. They're obviously very different. But with the robotic survey, the images were much fuzzier. So this is now an image from the Sloan Digital Sky Survey. This is an elliptical again, and this is a spiral. You can see that there's some kind of spiral features there. So this telescope produced a lot of these images, and the problem about this task of splitting these two objects, we want to know which ones have which shapes. The task is one still best done by human eye. When the images are fuzzy, the numerical algorithms that you try and use to do this task just aren't nearly as good as the human eye, in fact, just an untrained human eye. And so we needed people's help with this task because basically the data volume. So if we go back something like 40 years, pre-CCDs, pre-imaging using digital technologies, during your whole PhD, you'd be lucky to get maybe 100 images of galaxies during your whole PhD. So a research program might have something like 100 images in. As recently as about 2006, a group of astronomers might get a collection of maybe 10,000 images. Again, they classify them by eye as a team, and they do their research with a data set that kind of size. We had a PhD student, his name was Kevin Shavinsky. He was a pretty extraordinary chap. He managed to look at 50,000 galaxies just by himself in a month, which is pretty spectacular work. But even he was dwarfed by the scale of this Sloan Digital Sky Survey, this first release. There were about 1 million images in this data set. And so we had a problem. We knew that it was impossible to get a grad student to look through them all. Kevin flat out refused after the first 50,000. So the challenge was, how do you engage, how do you get the rest classified? So we made a website. It was called Galaxy Zoo. This is what the first version looked like. It was super simple. It just had a picture of a galaxy. This is one of those ones from the Sloan survey. And just a single question. Choose a galaxy profile that most closely matches below. So if it was a spiral galaxy, you picked which way the spiral was going. If it was an elliptical, you hit the big button for elliptical, and there are a couple of other buttons for if it was a star or two galaxies merging. And this website launched in July 2007, and kind of went crazy actually. This is number of classifications per hour we're looking at here in the first 2 days of the site's operation. So this little blip here is when the site launched, then the hardware failed. So there was a server at Johns Hopkins University. These guys, this local time at Johns Hopkins, this is like 2 a.m. Our website was hosted for free on a server at Johns Hopkins, much to the displeasure of their IT crew, who did not know this. And then this got on the BBC News on the front page, and literally the cable to the server kind of melted, and that was the end of that server. So somebody gets a phone call, please, can you put our website back online? Comes back online, heroic effort from their IT crew to get us back online. And within the day, we were doing something like 20, 30,000 classifications every hour. And we can put some units on here. This is your survey paper at 10,000 classifications. We're doing about a Kevin month of analysis every hour, 48 hours into launch. So there's this enormous volume of people who came to the project. So this version of Galaxy Zoo, there are 1 million images in there. We wanted about 40 repeat classifications of each galaxy. About 170,000 people came to the original version of Galaxy Zoo and produced about 50 million clicks analyses of this. Today, we're much further down the line. No, that's very bright. We're now up to about 700,000 volunteers across the whole Zooniverse who produced between them about 250 million clicks on something. Maybe it's a galaxy or something else. And so it's worth just spending a little bit of time just going through how we do science with the efforts of the community. So imagine your crowd of people who are clicking away on your galaxy. So this group of people have seen a collection of objects between them. How do we know if they're any good? Well, what we do is we take a member of the science team, so it's the person in green here, who will go in and classify some of the objects in the dataset. And then we basically look for people in the community who have seen the same objects as them. And so if the professional astronomer has seen the same objects or some of the same objects as the people in blue here, then we can make a comparison. We can check how good they are. So we can say they've both seen the same object. Did they agree? If they do, then we score the person in blue, give them a score saying this is a good classifier. But of course you can't compare against everybody in the dataset because the research team hasn't classified everything in the dataset. So you actually have to do a kind of second and third generation comparison between the objects that these two people share. So this might be this object down here. And you have to be a bit careful with your error handling, but you can basically produce science. It works. And so you can produce a lot of good science. So Galaxy Zoo just on its own has produced about 35 peer-reviewed publications to date, and looks like no sign of slowing down. Based on this kind of similar model, this is another project we launched a couple of years ago, which is called Old Weather. Either the most brilliant title in the world or the most boring. We have a split in the team. I think it's rather nice. But anyway, it's like two really boring things, old things. I think. Anyway, so Old Weather takes ship's logs. It's actually just switched to logs from the US Arctic fleet in the 1880s. But this version of the site, this is HMS New Zealand, which during the First World War was a circumnavigation vessel. And these are ship's logs taken from Royal Navy vessels during the First World War. So we're in 1919 here. And the point about the Royal Navy, and in fact most navies, is that they, without fail, every 4 to 6 hours, record the weather. This is just what they do. It's part of daily operations on the ship. And so this is a typical log page from one of the ships. This is the logbook of the officer of the watch. So this is literally the legal record of what was happening on board. And so you can see the ship's name, the date where they are. We're actually in Bombay here. And we've got wind direction, wind speed, a weather code, how cloudy it is, air and sea temperature, and air pressure. And the point about these logbooks is that the data are so, time, position, the values are so valuable that in these logbooks are so valuable. If you do optical character recognition on these data sets, you spend as much time correcting errors in the OCR than if you had just typed it out by hand. So there were groups of people at National Climate Data Center in Virginia, teams of people who were employed to do this, taking logbooks like this. And actually recent funding, this is kind of classic pork barrel funding in the US budget. Funding is now actually gone, doesn't exist anymore. And so we set up a project to invite members of the public to do this. The reason, of course, to do this is to understand kind of what was happening in what was happening in the weather 100 years ago. This is best visualized with something like this. This is Google Earth plot showing all of the data that we have as climate scientists for October the 16th, 1987. So this is, if you're British, this is a very famous day. We're centred over the UK here. This was the Great Storm, which was apparently only going to be light breezes and actually turned out to be one of the biggest weather events in the last 100 years in the UK. And you can see here air pressure. So the dark blue is very, very low pressure. So every point on this plot is a weather observation that is available to use if you're trying to do climate modelling today. And what the climate researchers do is they basically take this data and they try and generate a model of what the weather was doing. That literally across the whole globe, they say down to about 10-kilometre grid, what was the weather like at this point every hour? And they produce this mesh, this network. And so what we're seeing here is these lines, these are the isobars, the pressure, and the black arrows are the wind directions, but crucially, these lines and the arrows are the model, not the actual data. So you fit this model. So this is used to produce these models. If we go to the southern hemisphere at the same time in 1987, you can see again this is the same model, exactly the same point in time, snapshot in time. We're down, we can see we've got New Zealand, Australia, we've got South America here. You can see there's some observations, some of the Antarctic base stations, but you can see this fog here, what they call rather charmingly the fog of ignorance in their calculation, where they're not really sure what was happening. So this is where there's uncertainty in the model. So if we go back to old weather era times, this is now March 1918, this fog of ignorance now is way, way up into the North Atlantic, covers most of Africa, even though in fact there were weather observations, the colonial era weather observations being made, they're just rotting in a cellar somewhere in Kenya or New Guinea. There are lots and lots of observations of the weather here. We just don't have them yet. They haven't been recovered. So there's this fog of ignorance now up in the northern hemisphere. We get to the southern hemisphere 100 years ago. We have no idea what the weather was what was happening with the weather. And the point about old weather is that these data are used to basically predict or to measure whether the severity, frequency of extreme weather events are changing. This is long-term trends in the weather, which kind of allows us to infer things about the climate change. So the point about old weather is that these are mobile weather stations. They are ships that 6 times a day are recording all this data, and of course they move around the world. So this is just, if you go to actually this URL, you can actually get this. This is a Google Earth visualization, Google Maps, sorry. Is it going to play? Yes. Okay, showing over about 8 years. These are all the positions. So the positions here of the ships, and these are all the positions. So we can see different phases of the war. So you see kind of midway through, you see the US get engaged in the First World War. So the US is in the war now. And you see the positions and the tracks of all these ships moving. And of course, every point on here has about 24 weather observations to go with it. So these are mobile weather stations that are used and go into these data sets. And this is just kind of a static view of this. So these are all positions from the old weather project. So there's the odd kind of lat long area where that one might be real actually, because that might be a river, but there's certainly things that are almost certainly not real. There wasn't a Royal Navy ship in the Sahara, for example, like that. So you just have to be a bit tolerant of that. So the Zooniverse today is this network of these projects that engage members of the public in citizen science. And in fact, we produced a timeline the other day, which is kind of fun to share. So this is the last 5 years in Zooniverse. So this is the original Galaxy Zoo. And you can see we started doing we know lots of astronomers, so did lots of astronomy. Then this is old weather, and then more astronomy. We've got ancient lives, this is papyrology. This is whale FM, so this is listening to a whale song. We've got a text transcription project with the Bodleian here. Cyclone sensors is a collection that's been launched here. This is actually us in the Adler. We have a team now that are launching these projects. But there's this sort of ongoing kind of appetite in the research community for these questions that need people's attention. They need either people to help with a fairly straightforward task. Maybe it's transcription, maybe it's analysis. But these projects exist in many, many research domains. So these are the kind of direction we're going. I think it's worth talking briefly about why do people get involved with our projects, and these are some results from a survey that were taken a few years ago from the Galaxy Zoo community. So the people here who answered, they answered about 10 questions survey. These are just the responses to one of those questions. The question we're looking at the responses to here is what is your primary motivation for contributing to Galaxy Zoo? And there were lots of answers you might have guessed. People were saying, I like science, I like astronomy, I'm interested in the scale of the universe, I'm an artist, my friend sent me, I think this is not very good on the social networks, obviously. But this big spike here was, I see value in contributing to research. So there was a large community, this is about 20,000 respondents, by the way, to this survey. This was kind of a pretty important point for us when we first did this research. We without really designing for it, we built a project where we'd attracted people who were actually saw value in the research, the efforts that we were, the work we were going to do with people's classifications. They saw through that and said that actually I think that the astrophysics you're going to do is really interesting, and I see that. I'm like, that's my primary motivation for helping you. And so this leads us actually to today, to Zooniverse. We're still building with that model of building projects where there is a real research case and one that can only be answered by the community. We've actually distilled that into what we would call some ethics of citizen science. And these are some suggested, and it's a social contract, if you like. These are some rules that we use, and I'm not saying that these are the rules, these are just some example rules, for defining what is a good citizen science project. So these are the rules that certainly are applied to all new Zooniverse projects, and this is a set of opinions really, but I think they're worth sharing. Number one, our community is one of collaborators and not users, so that's a subtlety that I think is important. This is a community of people who, when we can, are cited on papers. Predictably, the first Galaxy Zoo paper with 175,000 authors on was rejected. You didn't need to know that, but when we can, we put individual people from the community in the author lists on papers. Most recently, I don't know if people remember, a couple of weeks ago there was a planet discovered with four suns. That was found by our Planet Hunters community. A couple of guys, Robert Gagliano and Kai and Jack, who are both actually here in the US. They're primary authors on the paper. It was discovered literally by these two guys in the forum. So when we can, we're crediting people. We always leave a link to a list of publishable names if people want to be credited for their time, then we do that. The second, and again this is just a Zooniverse kind of recipe for citizen science, is that we only take on real research problems. So we don't set these projects up to be educational tools, even though I think they obviously are in the right setting. They are not designed to teach people about astrophysics. That's not the goal of Galaxy Zoo. The goal is to do research in a novel way and in a way that makes best use of people's efforts. And the third is hopefully obvious, but not wasting people's time, is about if there exists another way to do your science that's equally good, then you should just do it that way. Asking of people's time is a big deal, and so you should kind of treat it carefully. And so hopefully that is pretty obvious, but this is kind of important to us. So today we've got a collection of projects that have just come out the door. I just wanted to show you a couple just because we're pretty proud of them. This is one with the Woods Hole Oceanographic Institute. They have an underwater rover that basically takes images of the seafloor as it's being pulled behind a trawler. So that's a scallop, that's a sea star. These things eat each other. I can't remember which way around it is. I think those eat those. These things obviously are delicious if you like scallops, and this is actually the project here is to try and dictate fisheries policy. So the HabCam project that's at Woods Hole Oceanographic Institute is directly linked through to how many scallops can be pulled out of the sea. So this is just a non-invasive way of measuring scallop populations. So size is obviously related to the age of the thing. So the other mode is to kind of dredge up the seafloor and count how many things you pull up, but this is a non-invasive way of doing this. We've got a project with National Climate Data Centre looking at 30 years of HERSAT imagery. So this is an image of a hurricane. In fact, it's a cyclone because we're in the eastern oceans here. But this is actually vaguely similar to Galaxy Zoo. This is a morphology question, so answering questions about the shape of the objects. The goal here is to work out whether the actual strength and severity of large weather events has changed significantly over the last 30 years. So this is a new project that's come out the door. And we're still doing Galaxy Zoo. It turns out there's a lot of galaxies that you can classify if you have the time. And just the last one I want to show you is this one called Bat Detective. So this is kind of a bit different for us. This is a spectrogram. So this is a visualization of the audio. So you press play and you actually hear the button, hear the bat call. This is data that's actually been recorded by citizen scientists using the iBats application. I don't know if you've ever seen it on the App Store. So you can buy an ultrasonic microphone, and they're kind of expensive, so it's not literally people just holding up an iPhone. But people drive through the countryside with a microphone attached to their car, and they just record in ultrasound the audio of the bats, and then we step down the frequency 10 times and then display it. So these are actually bat calls. This is an insect here, and this kind of rumble is some kind of background noise from the microphone. And the task is to actually kind of mark in frequency and time space where the bat calls are. The reason that this project exists, and I think this is an interesting model for citizen science in the future, is that this is a project that knows its own end. Like, we know when we're going to kill this project, and we're going to kill it when we can do this task as well using an algorithm as we can using people's time. And the reason actually the team at London Zoo came to us with this project was that the existing automated methods aren't very good at separating the difference between species. So you'll see that there's these different shapes. These are actually either different bat species or different types of calls. Some of them are social, some of them are feeding calls. But the existing automated methods are proprietary, so they're closed source, and pretty expensive, and they're not very good at doing a couple of key parts of the science that they need to do. So this is a project that's designed to produce a big training set of data to build an algorithm that can do it as well. I think it's worth saying to a bunch of people who might be thinking about taking on a citizen science project or exploring citizen science as a way of engaging members of the public, like, why do we think citizen science is good? What do we see as its core kind of values? And I think these are in no particular order, but there are, number one is, of course, the kind of citizen science that Zooniverse does has a scale argument. You can put 1 million galaxy images in and invite members of the public to classify those. So that's, this is kind of a scale argument. You can take on research questions that are too big for a small team typically. Number two is that you actually develop a measure of how confident you are in your classification. So Galaxy Zoo has produced by far the richest set of shape measurements of galaxies in the world. It's a pretty standard data set to be using now if you want to do that kind of science. So, and the reason it's particularly rich is that there's if 80 or 90% of people are agreeing about the shape of a galaxy, then we actually have an accuracy measure that we wouldn't have if we just had a single professional astronomer doing it. Again, these are in no particular order. These are educational tools. We are beginning to build classroom, both formal and informal learning experiences around our projects. For example, producing lesson plans to go with some of the projects, or seeing them used in the museum environment, which is home to me these days. And the fourth, and I'm not going to really talk about that today, is serendipity. There's something really special about having people look at a collection of data, so people notice the unusual. Algorithms typically find what you ask them to find, whereas people are pretty intuitive and usually are identifying lots of the unusual things. The discovery of Planet Hunters 1, this planet with 4 suns, is an example of serendipity. This was unusual, missed by algorithms, spotted by people, and there's something interesting there. And so we have this crowd of people online, and yet I work here. I work at a planetarium. I'm kind of new to the museum sector. I'm an astronomer by trade, and I don't think it's obvious how to translate what we've done on the web into a museum environment. And yet there is this tantalizing opportunity. The Adler's mission, it was built by a chap called Max Adler in the 1930s, and it's the mission of the Adler to inspire exploration and understanding of the universe. And I think, for me, when we see how people interact with our projects, how kind of discussion evolves online, the stories we hear from the community, who aren't typically in Chicago, clearly people are being inspired by the science, and citizen science is, I think, clearly a way to inspire deep understanding and engagement. And yet we haven't really done it yet. In fact, I read a blog post, which I'm sure lots of you have read, on Museum Next by Jim Richardson, that says, if museums see updating their websites as something which their marketing people can do in a couple of hours per week, then they are missing a huge opportunity to step beyond the walls of their institutions and settling for little more than digital leaflets. And I, unfortunately, think that the Adler Planetarium's website is pretty much a digital leaflet. It's got show times, we've got a flagship dome, we've got this amazing, genuinely amazing planetarium experience, and yet, all we do here, this is a classic example of a website that's trying to be everything to everyone. And so, my name's up on here with a biography about me. It probably shouldn't be. It's really not relevant, I don't think. So I think there's an opportunity for us. We're a web team within this museum and we're quite a new group within the museum, to try and work out how we can translate the engagement we see online with a remote community, where it doesn't have to be the goal to try and see increased revenue through the doors of the Adler. So there's a challenge here for us as a group, and we're starting to do stuff. So we've got a new gallery. It's a cosmology gallery that's just opened, and Planet Hunters, for example, is in there. So this is actually citizen science on the museum floor, but it's not a gallery about citizen science. This is just one piece in the museum. There's some people doing Planet Hunters here. There's been about 10,000 clicks from this interface since July, so people are using it. But it's only kind of first steps really for us. I think the other thing that we're learning is that when you have people, so we also run a program on Sundays called Citizen Science Sunday, and this is a member of the team here. Actually, I think they're doing Planet Hunters as well. But if we kind of have a kind of facilitated session, citizen science seems to work really well. So if you have staff, you have people, we've got projectors with Apple TVs connected, so you can hook up to it with an iPad or a laptop, and you can take over a projector just kind of randomly on the museum floor and start talking to people, engaging people in the project. So when you have people available, then facilitated kind of museum experiences seem to really work well with our project. But that's, again, just because it's explaining a website to somebody. So we've started to go down this path, and yet I feel like there's something more. So I think for us, the challenge over the next couple of years is to try and translate what we know works on the web and try and find models that work in the museum. And fortunately, I don't have a coherent story to tell you about how we've made it happen yet, but I'm hopeful that we can. There's a very cheesy Chinese proverb that I am going to say, and I apologise before I say it, because I do think it's relevant, and I read it on somebody's footer the other day. I don't know whether they had a cycling like wise words signature, and it says, "Tell me I forget, show me I remember, involve me I understand." And I think citizen science is about that. I think involve people in the core of what it is to do science, what the scientific process looks like, involve people in a way that they genuinely understand, and I think it's potentially a transformative experience in the museum sector. So, thank you.
So maybe one or two questions.
Oh yeah,
just while we're doing magical trickeries.
Yep. If there are any.
Nancy.
So I just want to launch something that I know you're not going to answer in 1 or 2 seconds, but just to kind of start the conversation. As Ellie well knows, I've totally drunk the Kool-Aid on citizen science and crowdsourcing. What I'm really struggling with, though, to get it to work for us at the Smithsonian, is how do you build the call to action? How do you build a truly engaging experience? And just as importantly, do the marketing around it so that people know. So anything anybody wants to throw out there as tips and maybe opportunities to kind of go a little bit more deeply into that, the design question of how you design a successful citizen science project, I'd just love to hear about now or later.
Shall we hold that? Or, I mean, I have, first thoughts for that are that it turns out that having this.
Sorry, can you just repeat the question?
Oh, sure. So, okay, so how do you, I'm going to make it very short, how do you design for a successful citizen science project? I mean, we're following a recipe that we think we understand, and that is about having the voice of the researcher front and center. So the message for us is always about how you can help a particular group or individual with a research problem. So making it a personal connection rather than, the first press release we ever put out for Galaxy Zoo said, come and look at pictures of galaxies that no other human has seen before, because we thought that was cool. And that was a true statement that nobody, they were all taken by a robotic survey. But I don't think that was a big, huge deal for people. I think actually it turns out that when we saw the kind of feedback on the blogs where we had researchers saying, your efforts have allowed me to do the following. I'm at a conference presenting work about your efforts. Like this is, you've literally changed the way I do research. Like a really strong personal voice from the science team. That turned out to be, I think, a really quite a defining feature for us. So I think, I know, been speaking to guys at the Cal Academy about how they're designing kind of museum systems. I don't know if anybody's here from Cal Academy, but they're making it very clear, like, who are you helping? Like, which people are you helping? And making it, I mean, it puts more on the researcher, but if you get the right balance of project design and effort on their part, then actually they're going to reap the rewards too. So, it takes finding the right kind of people.
Thank you. That's helpful because it's actually a little counterintuitive.
Right.
In that we tend, in a marketing mode, to put things in terms of how does this help our audience to try to get them to engage.
Right.
And you're actually suggesting a deeper altruism and generosity in our public.
Yeah, absolutely.
What really attracts them is actually the opportunity to help somebody else. That says something quite beautiful, actually. Yeah. So
I think that's what we think is true. But and that's how we write press releases these days. It's always about an individual or a small group. Yeah.
Okay, so I'd now I'm very pleased to introduce Jeff Holmes, who's the digital learning editor from the Encyclopedia of Life, and who's going to talk today about the Encyclopedia of Life and their collaboration with iNaturalist.
Great, thanks, Ellie. Well, thank you very much for having me this morning. I think this is a great opportunity. I haven't been to this conference before. I'm not really a museum person, although I work at a museum. I work at the Museum of Comparative Zoology on the Harvard campus. It's the research part of the museum that sits next door to the Natural History Museum, if you've heard of that before. Today I'm going to talk a little bit about what I call an open science project, the Encyclopedia of Life. How many people have heard of the Encyclopedia of Life project? So maybe half. And a collaboration that we have with another project called iNaturalist. So back in 2007 or so, the biologist E.O. Wilson gave a TED Talk where he expressed a wish to create a website that would aggregate information about all species on Earth in one website that would be freely accessible. And this came out of the recognition that biodiversity, as you know, is sort of at a crisis point with changes in climate and habitat loss and that sort of thing. And he was really concerned that we're losing so much information even before we have a chance to gather it. So by pulling all this stuff together, not only would we have a macroscope to sort of see everything, but we'd also start to be able to identify gaps and at the same time open it up for citizen science and others to make contributions. So, whoops, did I skip one? Yes. So what is EOL? So EOL is a website, as I mentioned, a place to gather information, aggregate it from mostly scientific sources, organizations, databases, but anyone really, and it covers all species, animals, plants, fungi, etc. And it was initially funded by the MacArthur Sloan Foundations and a set of cornerstone institutions. So each of the cornerstone institutions hosts a component group for the project. I work with the Learning and Education group, which Harvard supports. Our species page group, for example, is at the Smithsonian. The informatics group is at Woods Hole, and that sort of thing. So that's the sort of structure of the loose organization. But more importantly, I guess, are the content partners. And we have over 220 or so currently. And these are places all over the world. You can see Atlas of Living Australia contributes as well. Most of them are databases that have organized their data in a way that can be transferred and updated over time to the encyclopedia. So this is an example of a typical taxon or species page, just to kind of give you an idea of how the information is being displayed and presented to users when they come to the website. I was struck a little bit with what Arvon said about trying to build a website that's attempting to serve all audiences. We're in the same boat in some ways. So the EOL is supposed to be for scientists, for education audiences, for the general public. And it makes it really challenging. So I think when we think about presenting this and making it accessible for end users, we need to think, as you were suggesting, I think, beyond just the website but even on the website, other ways of presenting the information and bringing it together. So, but this is what we have today. This is sort of a version 2 that came out last year. Typical page, when you come to it, you land on an overview, so you see some representative images, a brief summary if it's available, and then a series of tabs along the top which can take you deeper into either media, maps, more information about names, for example. And then up here on the right, you'll see this is the blue heron is found in 7 classifications. So another important thing that EOL is doing is actually aggregating information about taxonomy, because there isn't just one tree of life. Of course, scientists argue about this and have many different trees of life, and they keep changing. So EOL aggregates those as well, so you can view that, and hopefully as well, by bringing all of the classifications together, it gives scientists a forum for starting to reconcile some of these issues. And then the other important thing that we brought forward with version 2 was more of the community or social aspect we wanted to bring out. And so you'll see down here in the bottom some of the recent activity that's been going on with regards to this page. And it's also been reviewed by 4 curators. So one of the differences between EOL and another open site like Wikipedia is that we have expert curators who sign up either for a species page or a set of pages, depending on their expertise, and they kind of monitor them. Information that's coming in that's not scientifically reviewed already, for example from Flickr, will get reviewed by a curator. So in terms of citizen science, we kind of think of EOL being serving 2 kind of different sorts of needs. One is getting information out, using it as a resource to look up information, find out more, that sort of thing. And then the other is as a place to make contributions. And just as an example, we get involved with efforts like bioblitzes, which are sort of species inventories that typically take place over 24-hour periods. So people come together in one spot, they find as many things as they can, work with scientists locally, identify them, that sort of thing. There's one every year in the States that's quite a big one with the national parks and National Geographic. And we work with them to try to figure out both how EOL can serve as a place to put stuff, but also what kinds of tools and other information can be provided to help actually at the bioblitz, so in terms of identifying things and that sort of stuff. So in terms of what we've been finding out about citizen science, last year we undertook to have a couple of workshops. We conducted some interviews and online surveys because we were interested in kind of digging a little deeper into what citizen scientists would want out of EOL and what kind of tools and features might be useful to them. So I've broken it down into 4 different areas: content, community, tools and services, and design, and follow sort of along the lines that you were talking with about the, in terms of content, citizen science scientists are really interested in finding a place where they can see authoritative information. So having a place where curators can vet content is seemed to be important, and as well being able to get feedback. So one of the things that is nice about EOL is that if you are a content partner, and you can do this in a variety of ways, but curators who vet your content will actually, you can get notifications about that. So if somebody says, no, that's not what you think it is, or there's a problem with the information in some way, you can get back that information. Which is also important for large databases like Fishbase or whatever, because now you have more people looking at the information. You're kind of expanding your ability to do curation on it. And access to data sets. This isn't something that EOL is doing very well right now. From the species page, you probably saw most of the information is descriptive in nature. So we're getting in lots of media. The text information tends to come in as descriptive. I didn't show you a detail tab, but under the details tab, there's a whole series of different topic areas. So it might be conservation, ecology, that sort of thing. But that information that's coming in is in the form of descriptive text for the most part. So this year we're launching a new effort to really try to bring in other types of data, which people are quite anxious to get to. And that applies to education audiences as well. They want students to be able to work with scientific data. Context is really important. It's one thing to have a website where you're presenting all this information together, but people, what they really want is a place to organize that information into meaningful ways. So if they're interested in a particular list of species for their local park or something like that, being able to pull together that information is really important. So we kind of gelled some needs out of that. Standardized data structures is something that EOL is already doing in terms of pulling data in, but being able to support more types of data. The problem with a lot of the scientific data right now, especially when you're trying to cover all species, is that specialists tend to develop their own systems within species groups. And so it's actually becomes very challenging to try to standardize across all of life. So that's an ongoing effort. And terminology as well. Again, if you're thinking about something like building an ecosystem, tool that might look at interactions between species. How do you define, what is the terminology you use to define those interactions when you're talking about something like pollinators versus predator-prey relationships and that sort of thing. So when you're trying to deal with a diverse range of data, then it becomes much more challenging, and it's it's something we're still struggling with. Community we identified as being quite an important aspect as well. So people talked about the advantage of effective communities. Not just from the communication point of view, but from the communication point of view, sorry, being able to mobilize populations. So having a place, and comes back to that question, how do you start engaging people? So being able to have a platform where people can share the information, get their friends involved. Obviously, other things are important as well, it seems, and maybe even more important in terms of trying to get people engaged. But also sharing the methodologies and the techniques about what people are doing is important as well. In international communities, we're trying to serve, we have content partners from all over the world, so we're trying to make this data available to people from all over the world as well and get people engaged. So EOL is a multilingual site. We're getting all of the at least the navigational parts of the site translated through WikiTranslate, and then there are a number of efforts underway to try to think about how actual content can be translated as well. That's obviously a lot more challenging. So in terms of needs, clear entry points for citizen scientists to find places to put the data and to go sort of where they are. So again, this idea of not just having a website that people can come to and you expect them to find, but actually going either through widgets or some other embeddable technologies to the sites that they're already using. And support for a wide variety of data types, I mentioned that already, and international participants as well. Tools and services, the most important thing I think falls under that idea of being able to organize information for their own specific needs. So being able to create lists in the form of either field guides or checklists, that sort of thing, customizing how the information is presented. Species identification tools is something that people really want and that we haven't been able to figure out, again, because of all the different formats, how to aggregate that information. So there are lots of different keys out there, so it's still a challenge to figure that one. And then services to push content, again, getting content to where users are. And then just some aspects about design. Ensuring quality, Arlen mentioned their sort of algorithmic approach, which is really important to make sure that if you're getting lots of data from people you don't know, how do you figure out if there's any value in it? So, and yet you want to have a system that's open to encourage as many people to participate as possible. So that balance of vetted and openness is challenging. And what we've done on EOL is if people contribute, for example, one of the most open ways, I guess, is through our Flickr group. So if you have images of birds or whatever you want to upload to Flickr, you share them with our Flickr group, tag them with the species name, and the next day they'll actually show up on the page that you've assigned the scientific name to. Now, so that's a really easy way for anybody to make a contribution. But again, you don't just want all these images of whatever they might be, not necessarily the species, showing up. So they do show up, but they're clearly marked as unreviewed until they're reviewed, and then on EOL you can filter those out if you want. And then there's a way for the community to rate information as well. So in terms of presentation, you can control that by having the curator tagged parts as well as rating of quality. Portable devices, I think that's pretty obvious. So let me just skip to the bigger picture here. So what we wanted to do with this other platform called iNaturalist was to let me do that to partner with another website that's already collecting citizen science information. And so iNaturalist is a great example of a website. It's similar to Project NOAA, which we've already heard about, as an open platform where people can upload information about things they've observed. You can upload pictures, say where you saw it. And one of the nice things about it is that you can ask the community for help. So I found, I took this picture of this frog, I uploaded it, help me identify it. And the community, and I think this comes back to that point about people wanting to help and sort of be civic. The community is amazingly responsive, and while you often will get it down to species level, you can easily, often within 30 minutes, you'll get it down to the family or genus level, which is pretty incredible. So this is the front end of their website. Really nice design. And, you can freely log in and start recording observations. But one of the nice features of the website is that it has what they call projects. And so for our partnership, what we did is took the idea of organizing information on EOL in terms of lists and checklists. We have this option called collections. So if you make a collection of something you care about, corvids for example, we have a way of converting that into an iNaturalist project. So when its collection on EOL is made into an iNaturalist project, it then shows up on iNaturalist, and observations that are made for that project are associated with that collection. And so what you end up with is, on iNaturalist, a way to, and by the way, those observations on iNaturalist will go into a greater pool of observations that aren't just associated with the project, but that's one way of organizing it. And then back on EOL, within the project, so this is another collection of state flowers of the United States. So here is a tab for iNaturalist observations, because this is one that's been citizen science enabled. This is a map showing the latest observations that have been made for species in this collection. So it's one way we're exploring, trying to marry this idea of a resource and other citizen science projects. And we're also thinking about ways where, or using this as an example, I guess, so that other projects like Project NOAA and that sort of thing, we can figure out how to merge those technologies as well. Yeah, that's about all I had. So I guess we probably have some time for some questions. But
We do.
thank you very much.
Nancy.
I'm sorry, I'm such a nerd. So I was just wondering, Jeff, if you know enough about the API from EOL, which I think is possibly the only open API associated with the Smithsonian, and I know it's not exclusively a Smithsonian project, to tell this group a little bit about what's there and what they might be able to reuse. And similarly, for the mobile app project with iNaturalist that the Smithsonian collaborated on, as I recall, that code is all open source.
Yes.
So could you just tell everybody what's there that we could all reuse, because these are people who might want to use it?
Sure. Yeah, no, that's great. Thank you for that question. And I should have mentioned that there's a mobile app for iNaturalist, which is really nice. So you can make observations in the field. I don't know why I didn't put a screenshot of that in. But if you go to EOL, just /API, there's a great web page there that will give you an entryway into what APIs are currently available. And I've used them a fair bit. One of the things I use them for is a field guide tool, which basically lets you create a customized field guide. So the idea behind that is that you again start with a collection, and it will then pull content from EOL for the species that you specified, and then you can pick and choose what you want to keep. So, and then print them out in various formats and that sort of thing.
So Ellie, could we then import our user-generated personalized field guides into your platform the
field guide platform.
And we could essentially, people could publish their own field guides for mobile devices and tablets,
Yes,
combining those two.
combining those two. Yep, yep.
Yeah, so this is just a quick example so somebody's created this list of species. They've made a description for the guide, given it a location, and then for any of the species, they've this is one of the pages. So they pulled in those images, decided what information they wanted to include, and that sort of thing. And then it can be printed out in a variety of formats as well. So this particular application uses, if I go back to the APIs, uses the Pages API in particular to pull any amount of text or images or other types of media, video, sound we also have as well. This version of the field guide doesn't support video or sound, but those can be accessed through the API. The collections API is really nice as well, because once you have a collection, then you can start to do lots of different things with it. You can use iNaturalist, for example. My latest endeavor is what I call the Ecosystem Explorer, where I'm trying to provide a platform for people to put in how species are related in terms of interactions. So again, the idea here is to use the collection API to pull in a collection of species. They show up as nodes, which I use the hierarchy API to go up and try to figure out what large group they belong to, whether it's a bird or whatever. And then I use the Pages API. If you click on a node, it's a little low on the page here, but what it's doing now is dynamically bringing in an image if it's available and a brief text description for the species. So those are some of the ways that you can start to build these other types of applications and do really interesting things using the APIs. I mentioned before that one of the problems with the data on EOL is that a lot of it's descriptive. We have some content partners that are providing, for example, this kind of information, how things are associated, particularly for predator-prey type relationships. Currently what I'm doing is just going to those pages. You can pull any of the individual data objects, so I can actually, for any taxon, I can pull the association data and then post-process it. So what I'm doing for this next version of this tool is getting all the association data and then using any of the, it's just by names too. It says this taxa is a predator of all these taxa. And once I have the name, I can do a search with the search API and get the EOL ID. Once I have that, then I can go and get images, text, or whatever information I want from whatever's on that page. So having that kind of information in a more computable format would be nice, and that's something we're working towards this year. But it's certainly accessible, and just right now, some of it requires more work than others. Sorry, that was a long answer.
I've got a question for the panel as a whole, I suppose. You mentioned a few transcription projects and things like old weather look like they're very specific to the actual source document. Are you aware of any more or less generic platforms for transcription where, if an organisation had a body of works that they just wanted transcribed but don't have the infrastructure themselves to set anything up, especially nothing specific, that could be used for that sort of thing?
There is one that a project called Transcribe Bentham used, and I think it's a Wikimedia plugin. I think it is generally available for use. My only concern about that, and I think the Transcribe Bentham guys would agree with me here, the issue with that is that it's a kind of one-hit thing. Like, you've got a big page of text and you just have to write it all out. And that actually is not a very nice way to break up a large task.
There's nothing.
And Jerry Bentham had really scrawly handwriting and wrote a lot as well, so that was a big challenge. So there, I don't believe that there are generic platforms available. That said, our newest version of Old Weather is open source. It's called Scribe. It's up on GitHub and under the Zooniverse repository. And actually, we built the current Old Weather using that. and actually the Bodleian Libraries, What's the Score, also uses that tool. So it's not a hosted platform, so there's still legwork to do to get that running. But we did release that. It's one of those things where now we'd probably consider doing it very differently. So I mean, we build projects on it, so it definitely works. But it's more about building a transcription template for a particular type of record. So it is. I mean, if you're interested in that, I'd be happy to tell you more about it. But
That's actually what we found too with developing the Biodiversity Volunteers portal for the Atlas, was that it worked better for the transcribers if you kind of tailored the transcription model to the thing that was being transcribed. So just putting up whole pages is time consuming, because you sort of you've got the whole page and you kind of can't stop halfway through, sort of thing. So we've put up projects where it was done line by line, so we just presented a line at a time, particularly for scrawly, difficult to read handwriting, which takes a lot of concentration. Only having a line at a time is actually a reasonable model. For the label transcription projects, we put it all out into fielded individual fields, so locality data goes here, date data goes here, so it is a little bit of kind of project specific. But there's also a talk about crowdsourcing and transcription tomorrow afternoon that Gaurav Vaida is doing, and I think his team has been developing new tools as well.
Hi, it's a question about Arfan. In terms of that survey that you mentioned, about people who are contributing to research, what else did you find out about the people who were taking part in it? I mean, can you tell us anything about their ages or their educational background, or indeed their global reach?
Yeah, so it's a biased survey in that it was people who were coming back for a beta of Galaxy Zoo 2, so it's the most engaged people. But I still think there's value in kind of understanding who that community is, because arguably that's the kind of community we're trying to build. Overrepresented by men. Probably not surprising, something like 70% men. I don't think that's very surprising, actually, for me, especially given, I think, how we see lots of our design was very masculine, and lots of the subject matter was kind of not. I don't know. It was just we built projects that I think a teenage boy would have liked, and so we try and avoid that now. Reasonably well, equally represented in age groups with how kind of patterns are on the web generally. So we were pretty well represented across all age groups that are well represented on the web, if that makes sense. And we are predominantly, we're still about 2/3 US, and in terms of our population. And at that point we were about the rest of it was UK and other English-speaking countries at that point. That said, Galaxy Zoo 2 and later we're all in Polish, and we got nearly a quarter of all our classifications from Poland. It was a really big deal. So language support is something that we're still bad at but trying to get better at. And not amateur astronomers, crucially, and I think that's a really important point. So science, the term in education research I believe is science attentive. So the kind of people who will read the science section of a newspaper, but they don't have a science degree. You're not getting a new audience you're not changing people's lives and getting them interested in science. They're already interested in science, but it's sort of, at the end of the day, if it was a story that was written on a website, then it was probably written up in the science section, so it was people who were already reading that. So
as a follow-up on that, in terms of access, there was a question before, how do you get people to start getting engaged? Does everybody for Zooniverse projects have to come to the website, or do you have a widget that you can embed in other websites that people might already be going to, like a science news site or something like that? Right?
Yeah, no, you have to go to the projects. Yeah,
okay. Always, yeah. Is that something you guys have thought about, or is there a reason you're not doing it? Or?
I think we thought about different platforms for citizen science, and we certainly we had a Galaxy Zoo application that we've actually just had to withdraw because it doesn't work on our new site. That's my fault. I'm meant to be responsible for these kind of things. But we saw a lot of people that worked. Actually, we put some effort into making that work offline. So if you were online, it would pull down like 100 Galaxy images, and you could just kind of crank through them. And the numbers that people were getting through on a mobile device were astonishingly high. So I haven't actually thought about trying to see the projects on other platforms. Sort of embedded in other environments. I think that'd be an interesting model.
Well, I was thinking almost like an ad, right? So you're reading something, or I don't know, it's just some website that you go to, maybe you're an iNaturalist, and you say, hey, there's a Zooniverse project about,
Right. Yeah.
characterizing frogs or something.
The one that I really want to try is an idea that is best coined as guerrilla transcription. So I don't know if this is a new term for people, but the idea that technically it would be possible to build a transcription UI that kind of injected itself onto a web page that you were in, and I think that would be really exciting for people like me who, the National Archives, for example, you can see a record of a document, but you have to buy the £3 copy of it. But if you just want to, there are copyright things where you would be allowed to type out what you see and collect. I don't know, guerrilla transcriptions potentially pretty exciting. So sort of inject a transcription UI somewhere where it's not retrievable in any other way. That appeals to me. But yeah.
There's another tool for transcription, a company called Microtask that worked with the National Archives.
Okay.
Finland, I think.
Okay. Yeah.
And it's really great because they broke up transcription into this little game where you basically type bits of handwritten text to get these moles to build a bridge.
Yes, I have seen that. It's brilliant.
Yeah, you have to pay Microtask to develop these things for you, which is problematic for an art museum. But it's a really effective.
And the mole dies if you don't keep typing, right?
Right.
It's really clever. Yeah.
Massive participation,
Yes,
and of course, really, really good results.
Yeah.
I have a question about Zooniverse because I work for an art museum and we have a massive set of image data, and we have the Library of Congress subjects headings, and we have no way to connect the two except for human intervention.
Right.
But with over 40,000 two-dimensional works of art, there is absolutely no way that one person can subjects classify all of those things.
Sure.
So we've actually submitted a proposal to Zooniverse.
Oh, cool.
That was rejected.
Oh.
But I still think that it's an excellent solution for us. I'm just wondering how would the three of you see this applying to arts data instead of scientific data?
Yes.
Image data specifically.
Yeah. I think, and we will only have been rejected because we got loads of very good applications. It's embarrassing. I was like, cool, I'll look out for that.
I'm not holding you personally.
That's embarrassing. I think there's significant value there. I think I gave you some ideas about how we think about designing good projects, and I think, we used to think that we used to do things like say to researchers, what are the first 3 paper titles what are the first 3 papers you're going to write in the first 2 years of this project? And actually, with things like Old Weather, we actually accepted as a group that there are efforts that are, you're building a corpus of information that will be of value. Right. There's no immediate, the Old Weather data is going into a simulation, I think, next year. They're so expensive, they happen every 3 or 4 years, right. Big supercompute runs. And so there isn't actually an Old Weather paper yet. But it's obviously producing good data, and we've written a lot about the results. It sort of hasn't officially passed the sort of line of being a good project, but it's obviously working extremely well. It's producing fantastic data. So with that and the kind of general transcription, we were thinking, well, actually, our model of what is sort of value is changing as a group. And I think as we get into, we played around a bit with some collections in papyrology and the climate sciences. I think there's a huge opportunity in the arts, and I think there's a project that's probably been presented that we had some involvement with called the Tagger with the Public Catalogue Foundation. I think that's being presented at this workshop. I think there's enormous opportunities there. I think
there's another public tagger called BBC Your Paintings.
Yes, that's the same one. Actually, that is the same one. Yeah.
Where that's crowdsourcing tagging, not using something as formal as the Library of Congress subject headings, but basically presenting works of art and saying, tell us what's in this. Red, field, poppies.
tagging, and,
Yep.
and the problem with that is that the Steve Museum project sort of proved that the data is all over the place, and the data, the terms that the public uses to describe art and the terms that the museum uses to describe art have very little intersection.
That's right. Yeah.
So, and there's the problem that it's not hierarchical, it's just this cloud of information. And so what we'd like to be able to do is to say, if you know the species of lily that this is, that's great. We'd also like it for everyone searching for just flower or lily, to find the same things. And it's just that, I think it's that it's too complex an operation. Maybe we just didn't sell it right. I don't know.
Yeah.
I think it is a lot of potential to transform the way that curators interact with each other and with the between departments and the way that people understand art. So.
But I guess with the tagging project, the interesting thing is about that the findings of the Steve project, where the official classification and the subject headings application and the folksonomy did diverge so much.
Yeah.
Then you have to go back and sort of question, well, so why are we going to put a whole lot of effort into subject indexing our artworks if then we go, but we'll put them on the web and no one will actually use those subject headings to search for the art anyway.
Right, yeah.
So that's why I think that, that having it, the hierarchy is the key to it, because otherwise you maximize the value of every single term instead of just saying this misspelled version of, of some animal is never going to be found. That's why I think it's inefficient. But.
We have similar concerns with our own internal data, the terms we use for the medium that something's made of.
Yeah.
Where a user would say clay, we have, hundreds of terms that would resolve to clay if we could take the tags that they use and plus our data and structure it.
Yeah.
So that then you could say there are types of clay, here they are. There's a sort of family tree of these types.
Yeah.
That would come from both tag data and from our own internal way of describing things.
Well, does that sort of suggest you have to do this in a couple of passes? Like you go up and you grab a bunch of folksonomy data, right? And then you try to provide some structure to it, so when you go back to the crowd, you can help them
organize the tags that
it.
they
Yeah,
make.
it's like if you're thinking about clay,
Yeah, just say we have thousands of terms, group them by a type. According to your sense.
Yeah, sort of scaffolding the process.
Yeah.
Yeah. Jonathan, we better make this the last question because everybody's tummies will start rumbling.
Just like going back to the question, how could this be applied more inside art museums? Just a few of the looking at what computers or at least the algorithms we come up with aren't good enough, or they're just slower in searching for image data. So if you have a lot of different images of the same, different levels of the painting, for example, and you can have a computer say, oh, I see like a bunch of lines here, but a person would say, wait, no, that looks like a sketch of a skull underneath here.
Mm-hmm.
This might be like an early sketch. That kind of research work is I think a lot of the researchers appreciate you pouring over their many layered items. So that kind of more academic research can be done, and then even for technology research within the museum, the methods used where you brought this facilitated citizen science, where you brought a bunch of people in, that worked really, really well for us. At the Met, when we did the hackathon, it was for us to figure out what the extent of 3D printers are being used in the art world. So like the questions of how newer, and there's going to be a talk later, how artists, newest mediums are technologies that we don't understand so well. That was a good opportunity for us to say, okay, when our curators look at artists who have 3D printed objects, they'll have a better understanding of, oh, is this an important work or not? So that was kind of research that was done. It wasn't the goal of what we were doing, but it's what, by bringing in 20, 30 artists, they were showing us new stuff. And it's a different type of research than the science museum, but I think it's still valuable.
Yeah.
Okay, thank you very much for coming, and please join me in thanking Arvon and Jeff very much for coming to both of them, their first MCN, and presenting a great session. So thank you.